Welcome to our lesson for today. We are looking at Venn diagrams. This is a follow-up on our lesson on sets, knowing the various types of sets and how to denote them and all that. So, let's say you have this example. First of all, Venn diagrams are just overlapping circles that are used to show the connection between sets. So, let's say we have this set. This is my universal set having this element 1, 2, 3 up to 10, and I have set A having the element 1, 2, 3, 4, 5, 6 up to 7, and then set B has the element 4, 5, and 8. I want to represent this set on a Venn diagram. So what I do is that I draw my set. First, you need to draw a rectangle to represent your universal set. Your universal set, which is this one. So you use this symbol for your universal set. So this whole rectangle represents your universal set. Now you draw these two sets in there. So I have my set A here and I have my set B here. So now that I have them labeled, and this is my set A, this is my set B. I need to explain a few things here before we continue. So the whole of this circle represents all the elements that are in set A. So the whole of this represents set A. The whole of this represents set B. And you realize that these two sets A and B overlap at this area. This is the intersection of set A and B. What they have in common, that's set A and B. The whole of the rectangle represents set A represent the universal set. So I come back to this set, and what I will try to do first is to try and find my intersection here. Find the intersection. So between set A and B, I find A intersection B. The numbers that are common, the elements that are common between this and this, there's 1 here, no, 1, 2 here, no. There's 4 here and there's 4 here, so 4 is common between them. No 5. There is 5 here and there is 5 here, so 5 is also here. That's what they have in common. So the intersection of A and B, the numbers that I put them here, so 4 and then 5. This is the intersection of 4 and 5. Now that I've written 4 and 5 in my intersection, all the other elements that are left in set A will come here. So those that are common to only set A, those that are in set A but are not in set B, so I'll call this place set A only. Those that are in only set A but are not in set B. So you realize that 1 is in set A but not set B, 2 is also there, there's 3, 4 is common to set B, so we don't write it, 5 is common, then we have 6, and then we have 7. You don't need to write them in any order, put them anywhere, so long as they remain in this space. And then those that are common to set B only, those that are in set B that are not in set A, they are in set B only. So you realize that it's just 8 that is in set B, that is not in set A, so you put it here. So you have your 8 there. But you would have realized that there are some members in the universal set that are not in any of these two sets, A or B. So we said that the whole of this rectangle represents the universal set. So members that are in the universal set but not in either A or B, we put them anywhere outside of these circles, but they must be in the rectangle. So you realize that there is which numbers are there? There is 9. There is 9 here. We have 9, so you can put them anywhere in the circle, 9. And then we also have 10. So it means that these members, these two numbers, are part of the universal set, but they are not in set A, neither are they in set B. So this is how you represent set using the Venn diagram, overlapping circles. All right. So we saw an example of how to represent set on the Venn diagram. You remember in our previous lesson we learned the various types of set, the intersection of set, the union of set, and all that. We want to look at how to represent all of that in the or on the Venn diagram. So if you look at this set, the number one, I want to shade the region that will give me A intersection B. Now A intersection B, the intersection we said is the point where the two sets meet, what they have in common. So where the two sets overlap, that's the intersection. So if I want to shade A intersection B, I will shade this side. This side will be A intersection B. So if you ask to shade A intersection B, this is what you shade. So this side represents A intersection B. The next one, I want to look at A union B. A union B is more or less like the summation of everything in the two sets. So everything in A plus everything in B. So if I want to shade this, I shade everything from here all through this place. So this will represent A union B. A union B. And the third one, I want to shade A complement. Remember when we were looking at the types of set, we said that the complement of a set are all those members that are in the universal set but not in the set. So if you are looking at A, set A, all the members that are in the universal set, the rectangle represents the universal set. So all the members that are in the universal set but are not in set A. So everything that is in this rectangle except the area covered by set A will be shaded. That will give you the complement of a set. And then if we look at the last one, I want to find A union B complement. A union B, all of this, the complement of all of this, A union B complement. So it means that I find the union of all of these A and B together, and then those ones that are not in that union will be my A union B complement. So those ones outside again here represent my A union B. I hope you are following. Okay, so we are continuing with the set of examples that we are looking at. So this time we have a universal set which is represented by the rectangle, and we are to shade A complement union B. A complement union B. So first we need to find the area that will represent our A complement. But we know that A complement represents all the elements that are in the universal set but are not in A. So all of this place will be our A complement. This side here will be our A complement. Now, if this is our A complement union B, so this one is not part of the set that we are considering. So if these are A complement, then A complement union B will be everything in B, including those that are in the universal set. So you have all of this side shaded. So when you find your A complement union B, that is what you are going to shade. We move on to the next one and we look at A complement union B complement. A complement union B complement. So if you look at the union of a set, we are looking at everything that is an element of A plus everything that is an element of B. So if we are looking at the complement, then everything that is in the union of A and B but not in the universal set, that is what we will be shading. So we'll be shading everything but the circles that we have here. So this will be our A complement union B complement. The next one is talking about just A complement. A complement. So if this is A, this is set B, and we are looking at A complement. A complement is everything in A that is not in the universal set. So in this case, everything in A but not in B, and then not in the universal set. So A complement will be the shading of everything but A. So you have all of this. Let me change my marker. You have all of this here. See all of this here, including this. So this will be our A complement, and then finally we will have A intersection B, all of that union C. A intersection B union C. So A intersection B, when you look at A intersection B will be here. So this is A intersection B. This will be what it is. And then this plus this one, the complement, the A intersection B, which is this one. Then that one union B, so union C, sorry. So you are adding everything in C to it. So now your shading will include everything in C. Everything in C here. So you have all of this side being shaded. Everything in C. You are adding C. So this will be the A intersection B in addition to the union. So this and this shade everything in D. So this is how we shade Venn diagrams when we are giving the specific instructions like we have on the board. We will move on and use actual numbers and see how we are able to fill in the various portions of our Venn diagram for any given question. Thank you.